Welcome to the Explainer. Today we're skipping the engine block and diving straight into the wheel wells to uncover the fascinating, high-stakes physics and absolute precision behind professional tire service. You know, we so often take our tires for granted. Most of us just kind of kick them in the driveway and assume everything is perfectly fine. But the sheer engineering and exactness required to keep a 2-ton vehicle safely glued to the asphalt at 70 miles per hour, it's absolutely incredible. So let's dive into this.
Here's how we're going to break this down today. First, we're meeting the master technician. Second, we'll tackle the surprisingly strict rules of tire rotation. Third, we'll explore precision mounting and balancing. And finally, number 4, the right way to safely execute a repair.
Section 1. Meet the master technician.
Before we get into the heavy machinery and, all the complex data, we absolutely have to talk about the humans doing this grueling physical work every single day. Take Grace Claudio, a BMW Master-certified automotive technician. She's a great reminder of the critical human element in this highly technical field. She actually advises her rookie self to, quote, "Stop underestimating yourself and give yourself credit for all you have earned." Surviving in this demanding industry requires tough skin, immense patience, and an absolute trust in your own hard-earned skills. We're talking about highly physical labor that demands intense, zero-mistake concentration.
And why does her expertise matter so much? Well, think about it. Your tires are the literal, solitary physical connection between your heavy, fast-moving vehicle and the concrete. There is no backup system for traction. If your brakes fail, hey, you have an emergency brake. But for tires, there's no plan B. This makes their maintenance, everything from checking the tread wear to ensuring absolute structural integrity, a true matter of life or death for everyone on the highway.
Section 2. Rules of tire rotation.
Since that solitary physical connection to the road wears down unevenly over time, thanks to braking, steering, and just normal road conditions, our first line of defense in extending a tire's life is rotation. Now, you might think a mechanic can just swap any tire to any corner of the car, kind of like rotating the cushions on a couch, right? Actually, scratch that. The physics simply won't allow it. For instance, directional tires have tread patterns specifically designed to aggressively channel water away from the car. They absolutely must point forward, meaning they can only be rotated front to back. On the other hand, sports cars often have staggered tire sizes where the rear wheels are physically much larger to handle the horsepower. Those can never be moved front to back. They can only swap side to side.
So the crucial takeaway here is that technicians have to evaluate this whole complex matrix of exceptions before they even think about touching a lug nut. They have to account for directional tread patterns, staggered sizes, and even specific drivetrain configurations, like whether the car is front-wheel or all-wheel drive. And here's where it gets really interesting. If a high-performance vehicle rolls into the shop equipped with tires that are both directional and staggered, you hit what's known as the no rotation possible scenario. That's right, no way around it. Those tires simply cannot be rotated at all. They're staying exactly where they are for their entire lifespan.
To prevent what could be a disastrous mix-up when applying all these rules, technicians rely on a beautifully simple, low-tech system. They use special, brightly colored tire crayons to clearly label each tire's exact new destination, writing things like left front or right rear right on the rubber sidewall. Then they carefully stage them on the shop floor in their newly designated spots before ever installing a single lug nut, guaranteeing a flawless rotation pattern every time.
Section 3. Precision mounting and balancing. Okay, once the rotation logic is totally sorted out and it's time to put fresh new rubber on the rims, we enter the highly technical, physics-driven world of mounting and balancing. Technicians use massive, heavy-duty service machines to safely break the bead and pry the tight rubber off without scratching the expensive metal wheel. But when mounting the new tire, they don't just slap it on blindly. They look for mysterious factory markings, like tiny yellow weight dots printed right on the sidewall. That yellow dot indicates the absolute lightest point on the tire's circumference, which they purposefully align perfectly with the heavy valve stem on the metal wheel. This ensures they start with the most balanced assembly possible, minimizing any violent vibrations before it even goes on a balancing machine.
But hey, those yellow dots, that's really just the starting point. For an even more accurate, perfectly smooth ride, modern high-end shops utilize an incredible process called road force balancing. Instead of just spinning the tire in the air like the older machines do, this tech actually presses a heavy, physical roller directly against the spinning tire. It simulates the exact weight of the car, plus the radial, lateral, and fore-aft forces the tire will experience when flying down the highway. It allows the computer to locate the absolute stiffest point in the rubber sidewall and correct for dynamic imbalances that a normal spin balance would completely miss.
As this balancing technology evolves, the construction of the tire itself is evolving too. Which brings us to a kind of surprising question about modern transportation. Have you ever wondered why the inside of a modern electric vehicle tire looks completely different than a traditional gas-powered car tire?
Well, it brilliantly illustrates the unique engineering challenges of EVs. Because electric vehicles completely lack a roaring internal combustion engine, sudden road and tire noise becomes incredibly obvious and deeply annoying to the driver in that super quiet cabin. To combat this total lack of engine masking, EV tires actually contain a thick, glued-in ring of acoustic insulation foam right on the inner liner. This foam physically absorbs the road sound waves, dramatically quieting the ride. It's a completely different anatomy from your standard gas car tire.
Now, perfectly balancing all these modern wheels, whether they're foam-lined EV tires or just standard rubber, requires attaching small physical weights to the rim. Historically, these weights were made of lead, but the entire automotive industry is actively shifting away from traditional lead clips. Why? Well, if a heavy lead weight happens to fall off your wheel at highway speeds, it ends up bouncing into the street, inevitably washing into local storm drains during the next rainstorm and becoming a severe environmental hazard that can literally poison local water systems. So today, shops use modern lead-free composite weights that are much, much safer for our environment.
Section 4. The right way to repair. Look, even the most perfectly balanced, foam-lined, totally eco-friendly tire is literally no match for a stray roofing nail in a construction zone. When a tire comes into the shop actively losing air, a technician's first diagnostic step is beautifully simple and incredibly effective. They submerge the fully inflated tire into a massive tank of soapy water and just rotate it. They aren't looking at sophisticated diagnostic computer screens here. They're watching closely for the telltale, steady stream of bubbles caused by air escaping the puncture. It visually pinpoints the exact microleak with perfect accuracy. It's just a really amazing contrast between high-tech balancing and beautifully low-tech diagnostics.
Now, if that damage is safely located in the thick centered tread, and let me be clear, never on the sidewall, because sidewall punctures completely compromise the structural integrity and just can't be fixed, the tech starts a meticulous repair. They use a rapidly spinning copper buffing wheel to physically roughen the inner rubber, carefully vacuum out all the resulting debris so the adhesive will actually stick, and then apply a specialized chemical buffing compound and cement. Finally, they physically pull a heavy-duty combination plug and patch firmly through the hole from the inside out, sealing it permanently and structurally.
And throughout this whole violent process, from using heavy machinery to aggressively break the tire beads, to heavily buffing the interior rubber with copper wheels, technicians have to be incredibly vigilant about one tiny, delicate piece of electronics. They must be extremely careful not to accidentally snap the delicate tire pressure monitoring system sensors, which are often hidden just inside the rim, attached directly to the base of the valve stem. Breaking just one of these turns a routine $20 tire fix into an incredibly expensive headache for both the shop and the driver.
So, armed with all this knowledge from today's explainer, you now understand the immense engineering, the high-stakes physics, and the careful, grueling labor holding your vehicle securely to the asphalt. The next time your steering wheel starts shaking on the highway, will you just blame a bumpy road, or will you respect the physics and get your tires' road force balance checked? Thanks for joining me on this deep dive. Stay curious and drive safe.